news channel that people are seeing right nowadays. That's Aaj Tak or see. I'm not. Hello, class. Very good evening to all of you. I hope you can hear me. Please tell me. Am I audible? Hi, Shrividya. Hello, Preeti. Hello, Siddhisha. Is it fine now? Is it some better now? Okay, perfect. So, what we are going to deal in today is about syllogism. And also, since we did not do our series practice yesterday, so we would be doing that today. I was just checking if some material is uploaded or not. I don't see it uploaded, so I'll contact the admin here to upload it so that we can try that as well. So let's wait for 2 more minutes for other people to join. Were there some more people in your previous class? Guys, should we wait for other people to join? I see only 4 people here in my class right now. Good evening, Madhuma. I think you are new to my class, right? Can you hear me, Madhuma? Hello? Can anyone hear me? Please type in yes or no. Okay. So today's class, it's going to be a bit theoretical because I would be telling you the concepts and I would be drawing some tables for you that would help you in solving these problems. So you won't require paper and pen to practice, but yes, if you want to make some notes, you can. So guys, were there more people in your previous class? Please tell me so that we should decide if we should wait or we should start. Only 6. Okay, then I think we are good to start, right? Okay, so guys, what is syllogism? What do we do? Yeah, inputs. Please tell me. I hope I am audible to all of you, right? Yeah, just try it out. Hello, Shikhar. Yeah, I am asking what is syllogism? Come on, people, give it a try. Okay, if you don't want to give it a try, just type no. At least I should know now what's. I would be clear if you know about it or I'm asking what is syllogism. Venn diagram. Okay. Yeah, rest of you. Preeti says Venn diagram. Same thing that Srividya said. Okay. Okay. So actually, how the question would be from this topic and what actually it is a way in which we provide evidences which are derived from the given statements. Let me explain it a bit. Suppose you are given statement 1, statement 2, statement 3, right? Then based on the three statements, if you are deriving on a conclusion, right? This process is known as syllogism. You guys get it? So what would happen, that there would be some premises given to you and you have to apply your knowledge to derive what does this imply, what's the meaning of this statement, and then you have to conclude, you have to get what it actually aims at, what's the meaning of that statement, and that would be your answer. I'm sure you guys must have dealt in with this kind of questions previously, right? So the statements that are given, right, these statements, they are called as premises. Okay, and the result that you draw from these is called as conclusion, as already written, right? So I can say there is a relational arrangement between the premises that leads to conclusion. Does that make some sense to you? Please tell me yes or no. Yes, yes. Okay. So I'll read out an example for you. You just listen it. Statement 1 says some of the Indians are men. Okay. Statement 2 says all men have a potential to be God. Statement 3 says some Indians have the potential to be God. So the three statements that I made, the first one, some of the Indians are men, all men have the potential to be God, right? These two were my premises, and the third one, some Indians have the potential to be God. That is my conclusion. Let me write it for you so that it becomes a bit evident. Okay, first statement. Okay, so these two were my statements. Based on these two statements, I conclude saying, right, this is what I concluded from the above two statements. So now I need to verify, like, how can I verify that my conclusion is correct or not based on the above statements? This is what we are going to deal in with this chapter, right? So did you guys get the basic idea of what is syllogism and what are we going to do here? Yeah. So what happens is, like, whenever you get statements, whenever you get a set of statements, the statements can be of various types, right? So based on the types, they have been segregated into the following groups. Let me write down the various groups on which the statements would, like the statements, the premises would fall into. The first one is universally affirmative statements. Okay. So what is, firstly tell me the meaning of affirmative. You guys know the meaning of affirmative? Guys, what is the meaning of affirmative? Any feedbacks, any inputs? What happened? Why are you all so tired today? I'm not getting many feedbacks. I think you guys like more practical classes instead of a theoretical. But in any case, we have to read this, right? Because this is an important portion. You might get ranging from 2 to 5 questions from this one. Guys, are you able to hear me? Please type in yes or no. I'm not sure if my voice is clear to you. Yes, yes. Okay. Yeah. So, okay, I'll tell you. Affirmative means positive. Okay. So, suppose I say that there is a statement example. I'll say all girls are good. Okay. So, this kind of statement where there is no exception. I'm not saying there are some girls they are good, or let's say there are few girls where there is total unanimity. There is no exception to any clause. They are the universal statements. And if the universal statement exclude any exception, it is called as universally affirmative statement. So as a thumb rule, what you need to remember is there is no exception to affirmative, universally affirmative statements, right? So if I say, for example, if I'm saying that all girls are good, which means if there is anything by girls, you can say for like any being, if it is a human being or if it is a thing or anything, if it is under the category of girls, it is ought to be good. You guys understand what I said? Which means all the girls present anywhere, that can be anything else, but it has to be good. For example, if I say all goats are animals, or I say all actresses are beautiful, or if I say all prime numbers are natural, right? These are all universally affirmative statements. And if I want to rephrase them, I can use them using the word only. Let me write it for you. Can be rephrased using only. So, for example, if I say all goats are animals, how can I rephrase it? Anyone wants to give it a try? If I say all goats are animals, how can I rephrase it? Can anyone try it out and rephrase it for me? No, Srividya, that's what I said. Shikhar, are you sure? Right, right. No, Preeti. No, you. When I said when I started it, I told you that there is no exception. So Srividya was wrong because she made an exception. She said some animals, which is wrong, and which is why Preeti is also wrong. Only a few, which by doing this you are actually making an exception. So if I want to rephrase it, I'll write it as only animals are goat. Okay. So the thing to make sure that you should pick here is, first thing, there is no exception to universally affirmative statements, and you have to apply it irrespective of whatever the actual meaning of the thing be. For example, in general language, a girl means a human being, right? Female gender. But if a statement is given to you in this portion, the syllogism, you need to make sure that you are not sticking to what is actually what's the actual meaning of the thing. Whatever it is, whatever the statement is, you need to make that hold true. Don't consider that girl is a human being. Maybe they are, what they want to mention is a girl is a thing, or maybe a vegetable or a fruit or anything, right? So until unless specified, you have to stick to the language without making any assumptions. Yeah, this is one area which is very important because most of the people, they make some assumption here. Say if I am saying all girls are good, I'm not sure, but maybe some of you can come up and say that means no girl is bad, right? Whereas that does not imply this. All girls are good means just all girls are good. That's it. You guys understood what I said? Okay. Now let's move on to the second category, which is universally negative statement. So what happens here is, say if I say no man is perfect. So what I am doing is, there are two entities involved in my statement. First entity is man, second entity is perfect. And what I am doing is, I am establishing a relationship between these two entities in such a way that anything or anybody who is under the category of entity man is definitely not going to be perfect. Does I make some sense, or should I repeat what I said? Please tell me yes or no, so that if there's any issue, I can repeat. Okay, Shikhar, I shall repeat it for you. This is my statement. Okay. So what I am doing is, I am saying no man is perfect. So this is entity 1. Okay, this is entity 2. What I am doing in my statement is I am establishing a relationship between these two entities in such a way that if anything falls under the criteria of entity 1, that is, if anything or anybody is man, then definitely that thing or that person is not going to be perfect. Simple, right? Say if the name of your system is man, then your system is not going to be perfect. So what's the difference between the first and the second? Ideally saying there is no difference between the first criteria and the second criteria, but only the thing is universally affirmative statements are positive and negative statements, they always will have this clause of no. Right? That's what the difference between an affirmative and a negative. I'm sure you must have done this in your grammars also. English grammar. Negative statements. Like if I say, as soon as I saw a leopard, I jumped. If you want to translate it to a passive voice, say you'll say no sooner than I saw a leopard than I jumped, right? As soon as is a positive one. If you want to change it to a negative one, then you have to use no sooner, right? I hope I'm making some sense to you. So the same thing for this as well, that there is no exception to universally negative statements. Yeah. Basically, the first and the second category are same, just that first one is positive, second one uses no, negative, negation. Now let's move on to the third category, which is particular affirmative statements. Now let's see what is this actually. Whenever I say that some movies are boring, whenever I use this word some, which means that there is an exception to my statement, right? So if I'm saying that some movies are boring, what I am doing is I'm accepting the relationship between the two entities. The first entity is movies, the second entity is boring, in such a way that some of the movies have to be boring, right? Which also implies that all the movies cannot be boring. Guys, getting me? Yeah. So, what more? I may assume that there is a thing called as movie. What is movie? As per a general acceptation, a movie is a video, right? What we see. But movie can be a person. Movie can be anything, right? So, in my statement, when I am establishing the relationship between two things, it does not depend upon the assumption that the movie exists. First thing. Excuse me. So the first assumption is movie may or may not exist. But if it exists, then there are some. Three, right? Do you guys understand this? I think I've not written my example here. Let me write my example statement. Yes. Fourth type is particular negative statements. So any guesses for this one, guys? What it should be? What type? Any example? Just try to derive the logical relationship between the third and the fourth based on the first and the second group that we did. Can any one of you try an attempt and explain what is a particular negative statements or any example? Right. Sirisha, some fruits are bad is a universal is a particular affirmative statement. You must have the word no or not in your statement to make it negative. I'm really happy that Preeti and Shrividya they have attempted it correctly. And Sirisha, do you get now that why are you wrong here? Why your answer was incorrect? Because as I explained in the very first thing that I said, all girls are good. Right? When I get this statement, I cannot conclude saying no girl is bad. Right? I cannot conclude it with this statement. So, if a statement needs to be negative, if a statement is lying under the category of negative, there would be definitely a word like, I'll write it for you, for a negative statement. It should have word like no, not. Right? For a universal statement, you would have no exception. For a particular statement, there would be some exceptions to the statement or say entity or say premise. Yes, I hope this makes some sense. So basically these particular statements, they give the impression of the statement being true in some particular cases and not in all the cases. Right? Let me write it for you. If I club both of them together, I'll write it. These statements are true only for some particular and not all the cases. Right? I hope this is clear. Very simple, right? Yeah. So, next is how do we represent the statements? And standard deduction. There are two ways in which we can represent the premises or the logical statements given to us to draw conclusions. Right, Srividya, that's what. The difference between a universal and a particular statement is Universal statement does not have any exception. It implies to everything, right? Whereas, oh, where it went? Whereas this particular statement, it's going to have some exceptions. It implies not, it does not implies on whole of the group or the whole of the entities, but a certain entities. Whereas for universal, whole of the entities. Correct? Any other doubts so far? Please tell me. Guys, any questions so far? Please tell me yes or no so that I can proceed further. No, no. Okay. So what I was dealing with was I was telling you about the two way to deal with these statements. The first one is the subject predicate method. Okay. The second one being Venn diagram, which all of you said when I asked what is syllogism. So we are going to deal with both of them step by step. And what we would do is the four categories of statement that we defined here. And let me make them highlighted so that you guys understand what am I referring to. This is the first statement, first category. This is the second, this is the third, and the fourth. Right? So for every kind of statement, we would learn how to make Venn diagrams, and for every kind of these statements, we would also learn how to use the subject predicate method. Although what I would suggest is subject predicate method is good only if you are very good at grasping up things, because there is a big table that you need to grasp. You need to just mug it up thoroughly. If you can mug it up, then only you try to use this one and apply it. Otherwise, I'd suggest you go for Venn diagrams, which is safe. And as we follow our technique of using more and more diagrams in solving reasoning questions, so this would fall in that category. And as far as I am concerned, I use the Venn diagram approach because I can correlate to it easily compared to the subject predicate method. Okay. So for the first type A, universally affirmative statements. See, what would the type of statements would be? That something like all A are B, where A and B are two entities and we are trying to establish a relationship. So if I want to sketch a Venn diagram for these kind of statements, it would be something like this. Now tell me, what should I label the inner circle and what should be the label of outer circle? Right. Inner one is A or outer one is B. Yeah. So what does this imply? It implies that there are two entities or two sets of data, A and B, and the set of data A is smaller compared to B. That means B has a bigger values compared to A, right? If I say that A is a prime number and B is a whole number, definitely it's going to be true, because prime numbers, they fall under the category of whole numbers. Am I correct? Yes. So guys, now a question for you. The question is, when I made a statement all A are B and I made a Venn diagram, Is there some other possibility? Can any other Venn diagram be made from this statement? Shikhar says yes. How would I make? Madhuma says no. Okay. If no, then it's fine. If yes, those who says yes, please tell me how would I draw? Shikhar says only one. Sorry, Shikhar. Shikhar, you mean that only this diagram is possible, or there is some other diagram that is possible with this statement? Only one circle required. Okay, what would I label it? Shikhar. A and B both. Rest of the class, do you agree with him? What happened? Yes, Shikhar is right. So both these diagrams, both these Venn diagrams, they are true for the statements, for the universally affirmative statements and the example that I made. Now, if you are clear about it, we can proceed further. If not, ask me why. I want to know how many of you want to ask me why. Preeti is asking. Okay. So, Preeti, actually, when I said all A are B, so you made a picture that there is going to be a set and a subset and A is going to be smaller than B, right? And in the second diagram, when I'm saying all A are B, look at the second diagram. And if I say all A are B, just try and explain me why is it wrong. Why do you think that diagram 2 is wrong when I consider the statement all A are B? Understood? Yeah, that's what. See, when I said all A are B, that means A is within B. A can be as big as B, A can be smaller than B. For sure, A is not going to be bigger than B. Right. I hope it is clear to everyone in class. If anyone you have any doubt. Yeah. One more thing that you need to make sure there are two deduction given. These are kind of automatic deductions that you can use further. Deductions are sum A R B. Second deduction is sum B R A. These are the two deductions that can be made from this statement all A are B. Okay. Reason being, if I say all A are B, and if I say some A are B, and I deduce that some A are B, I'm not saying, see, this is my statement, all A are B, and then what I'm deducing is some A are B. I am totally correct, right? Guys, please question me if there is any confusion. Yes, no. Anyone having any doubt on the deductions that are made from the statement? No, no. Good. So whenever there is any universally affirmative statement, we can deduce the particular affirmative statements from it, because if there is something universal, then the particular ones are also going to be definitely true. We shall deal in with this in the second method, that in the first method that I said about subject and predicate method, where we are going to draw the table. I think that would become more clear to you in case if you have any confusions, although I don't think so that you would be having, right? It's logical, right? If I'm saying if all of these things are following something, then some of these things are definitely following something, and something is being definitely followed by some of the like uh, entities of first class, right? Now let's move on to universally negative statements. How to represent them? Universally negative statements. Example, I use no A is B. No A are B, sorry. If I say a statement like this, how can I draw its Venn diagram? Separate circle, correct. There is no relation between them. Okay? And there is just one diagram, one Venn diagram that we can draw for this. Okay? And what are the deductions that we can make out from this statement? The first one is no B are A. Second deduction is some A are not B. Third deduction is some B are not A. Guys, do these deductions make any sense to you given the statement? You guys have any doubt in any of these deductions? Please tell me yes or no so that I can explain. Second and third, please explain. Okay. See, see, I'll draw. Suppose this is a big rectangle and this is a circle. This is a family of rectangle and this is a family of a circle. So, when I say that no rectangle is a circle, that means all the rectangles, let me use the pointer, all the rectangles here, they are not circles here. Correct, Shikhar? That means if I pick up some of the rectangles from here, not all the rectangles from this family, but just some of the rectangles from this family, they would also not be lying in the family of circle. Does that make some sense, Shikhar? Now, if whole of this thing is not falling in family 2, then some of this thing will also not fall under the family 2. You get what I said? Yes? Any doubts? And Srividya, what's your question? One is related. I did not get your question. Srividya, can you please explain more on your question? Shikhar, it's clear now? No B R A, right. When I say no A R B, they are not joined. So vice versa will also hold true. Suppose, say, if I'm saying that no A is B, there is no overlapping. So if I'm at this point, can you see my pointer? Let me use a rectangle. Yeah, if I'm at this point, which is lying under A, it's not B. Correct, Srividya? Yeah. Now if I am here, so does this lie under A? This portion which I have just drawn? No. So there is no exception to it, right? If I say no A or B, which means no B or A. And the second and the third one I have just explained. I hope that is clear, Srividya. Yes? Okay. Just keep in mind that the deductions that I am doing there here, they are definitely true. There is no circumstance in the which they are going to be false. So you can actually learn them up. Yeah, let me open the whiteboard. Now let's deal in with particular affirmative statements. PA statements. How can I draw? So suppose if I say some A or B. How can I draw this? Tell me the Venn diagram. Part of A is B. Correct. So there would be two overlapping circles. Right? Yeah? Any doubts? So when I say some A or B, what can I deduce? Deduction is vice versa. Some B or A, which would again hold true. So this is a definitely true deduction. Whereas there can be some probable deductions as well. Probably true deductions. Can be some B are not A. These are the two deductions that I can make from this statement. The first deduction is going to be definitely true. The second deduction may or may not be true. Because, reason being, I'll tell you. Suppose if I draw a diagram like this. Okay. And I said some A or B. Yeah. When I say some A or B in the diagram that I've just now drawn, am I correct? Yes, I am correct. If I say some B are A, as you can see in the second diagram, if I say all B are A, would definitely from the deductions that we derived, I can say some B are A, again that would be true, correct? So this is going to be definitely true. And the probably true deduction that I said some B are not A, which is false here, right? So this deduction is true here, but it fails for the second Venn diagram. You guys got it? Why I said that the first statement is definitely true, but the second statement is probably true? I've shown you an example where it can be false, right? Yeah. Okay, now moving further, particular negative statements. Particular negative statements. Example can be some A are not B. How can I draw this? Again, the same diagram that I can draw. Using the eraser, I'll just use it to make this dotted. Yeah, this is A and this second one is B. Now let's see what, guys, can you just try and tell me what deductions you can make from the statements? Shikhar, I think you are incorrect here. Preeti, uh, no Madhuma. Anyone else who want to try, or any any improvement in your answer? Those who have answered it incorrectly. No deduction. Guys, come on, just think. Just try to think. Okay. Now let me tell you what the deduction is actually. What we can deduce is all A are not B. So you guys notice what was the difference between your deduction and the actual deduction? Why? Why? Okay. I'll explain it to you why. See, when I said this is a particular statement, this is a particularly negative statement, right? So it gives me first thing that I can say is this statement is going to be true in particular case and not in all the case. Let me write it for you so that it becomes a bit easy. It gives an impression that statement is true in some particular and not all cases. Okay. So what you guys deduce, some B are not A. Shikhar, you deduce this, right? Your reduction is not a definite deduction here because your statement can fail. There's nothing given about B. All A are not B. See, I said some A are not B, right? So that means a part of A, suppose this is A, this was complete A, and I said some A are not B. That means there's going to be a part of it which is not in B. Suppose this much part is not B, or say this much part is not B, or say whole of A is not B. If I say whole of A is not B, that again holds true because out of 100 marks, if I am saying you did not get 100 mark, then I said you did not get 90 mark, then I said you did not get 80 mark. Are you able to make some relations between what I'm saying and what I have written here? How have I deduced the statement? Does it makes any sense now? If a part of something is missing, then the total of something would not be available in the second thing. See, let me write a statement. If a part of entity A is missing from entity B, then the whole of entity A would not be included in entity P. Oh my god, we've just run out of time and I haven't started with series. Shikhar, the statement that I've just written for you, does it make any sense to you? Yes? Does this make sense to everyone in the class? Yes? I think we have to stop here. We have just completed the Venn diagram thing. I'm left with the subject predicate and how to approach with the question. I think we have to carry it forward for tomorrow. Okay, no problems. I'll just check if my series is uploaded. So guys, I think it made some sense to you people today, whatever we did. Don't see my content being uploaded. Oh. What I'll do is I'll try to upload it from my desktop. Just a minute guys, I'm just trying to upload it from my desktop so that it becomes available to you. We shall try questions on this. Shikhar, we have not completed the topic as this being a bit theoretical topic and it takes some time. So we are going to deal with tomorrow. The questions, we'll practice them. I'll try to quickly cover up the theory which is left, maybe in the first of the class, and then we'll try the questions, right? So meanwhile, what you guys can do is what we have covered today, you can try out some questions based on whatever we have deduced. Guys, are you able to see this? Okay, let me try to bring it down. Are you able to see this image that I have uploaded for you? Is it visible? Can you guys please try this question, this figure? I am highlighting it with a rectangle. Okay, I shall zoom it out for you. I'm not sure if I'm getting the option to zoom. I'm so sorry guys, I'm not getting the option to zoom it because I have uploaded it from my desktop. So you need to try out this one. Not visible? The second one, the figure which is below, is this visible to you? Is there some option to zoom it? No, there's no option to zoom it here because I have uploaded it from my desktop. Selection tool. Now it is visible? Oh, good God. Yeah, please try out the first one and then the second one and tell me the answer. Answer for the first one and the second one, both of them. Okay, first is C. And the second one? Right, second one? Preeti says D. Shikhar says D. Any other inputs coming in? Now, quickly tell me Anyone who wants me to explain? Both of them are correct. The answer for the first one is C and the second one is D. Please tell me if anyone wants me to explain any of them. Any of them. Please tell me. Shivida, you want me to explain? Which one or both? Both. Okay, okay. Let's see quickly. So what's happening here, Shivida, is in the first figure you see there are two circles and an arrow in the northwest direction. In the second figure, what you see is, and the arrow at the northwest direction, which was earlier in the upper half, went to the lower half. Okay, same thing you have to follow here, that there are two squares here in the center. So in our answer figure, we are going to have just one square, the outer one. So we can safely remove A, B, D, and E. We are left with only C. Okay, this was pretty easy. Shrividya? Yeah? Now, in the second figure, just see that there was a rectangle with one diagonal. Upper one is having a circle, lower one is having an arrow in the northwest direction. What it became? The lower half of the diagonal, lower half portion after the diagonal, it was erased, right? And the arrow, which was earlier at the northwest direction, came to the northeast direction, right? So, following the same hints, in our third figure, what's happening? We have the diagonal in opposite direction this time, right? So what would happen is, if you just check, either this top portion would remain or the bottom portion would remain, right? So firstly, you have to look at the figures. Based on that, A can be a probable answer. B is definitely not going to be the answer. C does not qualify to be in the answer because if you see the shape of this portion, it does not match with any of the shape in figure 3. So we can eliminate it. D can be one of the probable answer. E cannot be the answer. Let's cross that as well. Yes. Now what we are left in with is A and D. Moving further, the northwest arrow became northeast. So here the southwest arrow should become southeast. And the southeast arrow is only in figure D. So we eliminated A as well. Make sense? Shrividya? Yeah? Let me open another whiteboard and try to upload the next figure from my desktop. I'm uploading it, guys. Need some time. Guys, these are three questions actually. I'll just outline them for you. This is the first one. This is the second one. And the lower one is the third one. Guys, is this visible to anyone in the class? Please tell me yes or no. Shikhar, it's visible to you. Shrividya, it's visible to you. Please attempt the first one. Preeti, is it visible to you now? Please attempt this one. Preeti, it's not yet visible to you. So there's nothing coming on your screen, Preeti, or you're not able to see the picture clearly? Preeti? I think your net connection might be slow. Just wait for a minute or two, might be then. I'm extending the class by say 10 by 5 more minutes. I think we won't need more than that. Yeah, for the first one, I've started getting answer. Now visible, please attempt. I'm so sorry, Preeti, for the inconvenience and everybody else in the class. Second one, okay. Yeah, just answer it. I shall tell you all the answers later on. Attempt the next. What's the answer for the last one, guys? Okay, very good, Shikhar. I'm really glad that you have answered everything correctly and you have maintained your timing. Right, Madhuma, the answer for 3 is B. Right. So the answer for 1 was sorry. For 2, it was D. For 2, it's D. Preeti, I think you have attempted it incorrectly. For question number 2, it's D. For third one, it's B. I'm really glad most of you have attempted everything correctly. Preeti? Yeah. So anyone in class who wants me to explain, please tell me yes or no. No. So now I think you guys are getting some confidence in solving these picture-based questions. I just brought 5 questions, Shikhar, today because I knew it's going to take some time for theoretical class, and theoretical classes are a bit cumbersome compared to the problem-solving classes. I find them more interesting. So there were just 5 questions for you today. Tomorrow I'll try to get at least 10 again, and yes, we are going to solve. We have to complete some theory, some the leftover theory of the chapter, and then we have to practice, and then we'll be doing series, right? So what I can suggest you is, since we have started with syllogism and we have completed most of the portions, like we have completed how we are going to draw Venn diagrams. It's just the subject predicate method left that I'll be explaining tomorrow. But I think you guys should be able to attempt the questions based on it. So in case if you guys get some time today or tomorrow before the class, do try to attempt some questions based on syllogism. Yes? Yeah. So just if you want, you can just write down the theory that I've given to you because it is interesting. It's important actually. I've just given to you the very essentials of this that you should know. Otherwise, you can get n theories, n pages of theories and everything, right? Yeah. So any questions for me? Tomorrow again, we are having a reasoning class for this week. Srividya, that's really bad because I've given you uh, a heads up a week earlier. I wanted every one of you to attend it. But no problems. Yes, in case if you have any issues, you can definitely email me. But if it is possible for you, I'd suggest try to attend the class. Or in case if many of the people who are trying to, if you are going to bunk the class next week, then please tell me so that I can reschedule this, because I want all of you to attend that in person. So just let me know by this Friday, because I'll be giving my timetable only after Friday. In case if more than one of you are trying to, if we are not able to attend the class in person, then I'll have to shift it one more week ahead. Yeah. So Madhuma, are you new to the class? Is it your first class today? Yeah. So can you tell me like what's your educational background or the highest qualification you have? MBA. Okay. Yeah. So that's fine. So anyone else want anything? Any questions for me? Finance and HR. So you must be comfortable with mathematics and reasoning, right, Madhuma? Okay, that's good. Yeah, so class, anyone, any questions, or shall we wind up for today? In case no, then I shall close the session now. See you all tomorrow. Good night. Have a great dinner. Yeah, bye-bye. Excuse me. Yeah, bye.